Good morning, students. In the last lecture, we have completed trigonometry. Now, in this, I will be covering the chapter 9 of NCERT class 10 mathematics, some application of trigonometry. Before starting this, I need to start with some basics of trigonometry and application of trigonometry. So, what are the application of trigonometry? You have studied that for a triangle we are given theta and any one distance is given, then you can find this can be find out one length can be find out, or if two sides are given you can even find the angle of theta. So using these applications, during this property of trigonometry, it helps to find various distance height objects and have applications in various space time and other applications. So let me start with how can you apply this. So consider this, I'm just taking an example. The basics of this is, let's suppose this is my angle theta. This is a person standing on the ground. Suppose this is a pool. Now what is this angle here? This is the angle theta is known as angle of elevation. Angle of elevation. Why? Because you are uplifting your eye, you are elevating your eye upwards so that you can see the top of the pool. So this is known as angle of elevation. The opposite of angle of elevation is angle of deviation. What is angle of deviation? Suppose you are on a top of a building. You are on top of a building and you are watching suppose a point on the ground. You are observing this rock. So according to this, you will need to bend your eye downwards, which implies that this angle, this is parallel to the eye, is this. And this is parallel to eye, this. So you are deviating the angle downward theta. This will also be theta because these two lines are parallel. These are parallel. Theta. So this angle is known as angle of deviation. Angle of deviation. Now you are deviating depression. Sorry, no deviation. Angle of depression. DEPRE is because you are depressing your eye downwards so as to see the particular object. So this is the basic, that angle of elevation and angle of deviation is the basic, and the object which is directly in your sight, right? This is you, they are seeing some object in straight line. This is object in this is known as line of sight. Line of sight, LOS, line of sight, LOS. This has its application in towers, line of sight, and the angle of elevation, angle of deviation has its application in finding the height or the distance between the two objects, or many things. So let me take some examples. My own examples, not from the book. My own example. Suppose what it says that this was a person of height h1 standing at a distance of 40 meters from a pole on the ground. So I can just the ground is saying that he is standing a 40-meter distance from a pole of height not known. Height is not known. Now it is given that the height of a person is 1.5 meters and the angle of elevation to the top is, let us suppose this is 30 degree. So according to this, my angle, this angle will be 30 degree. Now it is said that it is to find first uh, height of the pole, second you need to find this distance, walked. So if you see this figure, you can infer from this that this also, since these are parallel, so this will also be 40 meters, and this height is also, this is a become a rectangle, so this will be 1.5 meters. Now if you apply the, I'm supposing that this is my A, this is B, and C. So uh, and you define this AB is equal to what? So let, I'm supposing let this, consider triangle ABC. Angle B is, the angle of elevation is given to be 30 degree. So you know that I am applying C. You need to find the height of the pole. So height of the pole is, what? This is AC plus 1.5 meters. This is height. This plus this much is the height of a total height of the pole. So if you apply this tan of theta, where theta is angle B, so tan of theta is given as AC by BC. This is perpendicular by hypotenuse. So what is theta? This theta is given to angle B, and this is 30 degrees. So tan of 30 degree is equal to AC, you don't know, and BC is given to be 40. You know that the tan value of tan theta is 1 by root 3, which implies that value of AC is nothing but 40 by root 3 meters. Now this AC is not the height, because AC is the height minus the height of the person. So if you substitute this AC, the total height will be, height of pole will be, it is 40 by root 3 plus 1.5 meters. This will be your answer. Now it is said that find the line. It can also, instead of EV, you can also write it, find the line of sight distance. Line of sight distance. This is line of sight distance. LOS, line of sight distance. So what is line of sight distance? Now you need to apply this. Instead of this is, you are given BC, and this is AB. You find AB. So based upon hypotenuse, this is based on nothing but cos of theta. Cos of theta will be 40 meters as base. One height is AB. Now cos of 30 degree, this is cos of 30 degree equal to 40 by AB. Now what is cos 30? Cos 30 is 3 by 2. 40 by AB. Now if you find this value, this is nothing but AB equal to 80 by root 3 meters. This is line of sight distance. So here this is line of sight distance. This is a simple question. It is given that this is line of sight. So applying this trigonometric value, you have calculated the distance of height of pole and line of sight to the top of the building or pole. And then next is, suppose a person, this was a question on angle of elevation. Suppose a person is on a building of height unknown meters, or say you, this time I'm giving you the height of building. The height of building is 100 meters. And a person of height 1 meter standing on a building and looking at the stone which is at an unknown distance from the building. Now the angle of this angle of depression is given to be, I just suppose this is given to be 45 degree. Now find the distance between. So it is said that it is given 45 degree, and there is a stone. Suppose there is a stone here lying here, negligible length. Now find the distance between the building and the stone. So this distance you need to find. This is not known. This you need to find, and also you need to calculate the line of sight distance. This is LOS distance. So how will you do that? So First, if you see this, first make a triangle diagram which will make it even more clear. So this is your triangle diagram. Showing into triangle diagram. This is only shown in the dotted line, as a dotted line. And there is a stone here, so I will be using some distance of stone. And this is angle given to be 45 degree. This is 1 meter. The person height is 1 meter, and this is 100 meters. 100 meter tall building. Then this is a stone, and this is the ground. And you know that this is 90 degree. And so since this is a 45 degree, so this is alternate interior angle. You can see that even this parallel, so this electrical option, so this is be 45 degree. Now let me make this, name this triangle. This is A B C D. Now in triangle A C D, so this is a complete triangle. AC is given to be 100 plus 1, that is 101 meters. Now, and angle D is given to be 45 degrees, and angle C is 90 degree. So if you need to find the distance, that is, what you need to find is, you need to find this question mark value, you need to find this, and line of sight distance also you need to find this. So what you need to do is, you need to apply this. So you can see that this, for with respect to this angle 45 degree, my AC will be perpendicular and CD will be base. So tan of 45 degree will be nothing but AC by CD. AC is given to be 101. You can calculate that this is 101, and CD nothing. But you all know that the tan value of tan 45 degree is 1, which implies that C value of CD is nothing but 101 meters. So you have inferred that this location of stone is 101 meters from the building. Now you need to calculate the line of sight distance. So what is line of sight distance is? Here it is shown as AD. What is AD? Now how to calculate AD? So if you want to know that this is AD and this is AC is given, so with respect to theta, this is nothing but perpendicular hypotenuse. So perpendicular hypotenuse is nothing but sine of theta. So sine of 45 degree nothing but AC by AD. So what is AC? AC is, we have already considered 101, and AD you don't know. And but you know that the sine of 45 degree is nothing but 1 by root 2, which implies that AD is nothing but 101 by root 2 meters. So line of sight distance AD is nothing but 101 by root 2 meters, and the distance location of stone with respect to building is 101 meters. This was another example where angle of deviation was given. Now next is, I'm going to next this. Let me make this one. So let's suppose there is a balloon, small balloon, negligible length, not white, to make with different colors. And with respect to, no, first this was this, no, next let me suppose there was another question. Yes, what is this, that there is a pole standing straight to the ground. With respect to ground, straight, it always means that it will be 90 degree. The sun in east direction, rising from east direction, makes this pole, the length of shadow made by the sun on the ground is of length, suppose 10 meters, and the angle of depression of sun is given to be So let's suppose this is 60 degree. There is a sun here, and the length of shadow uh, of this pole, which is due to the sun, is of length 10 meters. Then it is said that question is find the length of pole, comma. The second is the distance between top of pole and top of shadow of the pole. The distance between top of the pole, that is this distance, and the distance of this to this. You need to find. So how will you do this question? So you need not to deploy much brain. So since this is 60 degree, which implies this angle also will be 60 degree. Since these two are parallel, so this will also be 60 degree. Now I will be renaming this as, this is my A, this is my B, this is my C. So in ABC, so in triangle ABC, what to know that this angle B is 90 degree, and angle C is 60 degree, and this BC is given to be 10 meters. That is length of the shadow is already given. Now you need to find the value of the height of the pole. That's AB equal to what and AC equal to what. You need to find. Now directly applying this formula. So in triangle ABC, you know that tan this, see, A is, you need to find AB and BC is given. So this is respect to 60 degree. It is tan of 60 degree is, you know that this is nothing but AB by BC. Now AB is, now you don't know AB, but BC you know that's 10 meters, and the value of tan 60 is root 3. So which implies this is equal to root 3. Which implies the value of AB is 10 root 3 meters. The length of the pole is 10 root 3 meters, and the length of shadow is already given 10 meters. Now you need to find AC. Now how you find AC? So there is two methods that you already have calculated 10 AB. You know BC, and applying Pythagoras theorem, you can calculate the value of AC, that is AB square plus BC square, and the root will be AC. Now, but using trigonometry, it will become more easy. So for reference AC, BC is given AC. So this is according with respect to 60 degree angle. This BC is base and AC is hypotenuse. So base by hypotenuse is nothing but cos theta. So this is cos of 60 degree, nothing but BC by AC. Now BC is already given test to be 10 meters, and AC is not given. 8 AC and cos of 60 degrees, which implies that from here, which implies that this is equal to half. So which implies that AC equal to 2 into 10, which is nothing but 20 meters. This is nothing but the line, the tip distance between tip of the pole and the tip of the shadow casted by it. This was the question in what it can be asked in freeze time. Why I am saying freeze time? Because here there is no rule of time. But in my next question, I will be showing how time will play with you. So, suppose there is a balloon, flying balloon, filled with helium gas of length, negligible length, balloon, and with respect to, let's suppose there is a ground here, and let's suppose with respect to ground, there is an inclination of then an inclination of 30 degree. Now 30 degree with respect to point P. So, not 30, no, sorry, 60 degree. Let's put this in 60 degree. Okay. Now it is given that after some time, let's just suppose this is 10 seconds, the angle of elevation from same point P to balloon, assume moving horizontally in air, is 30 degree. and it is given that 30 degree. Now first, what is you need to find is first speed of balloon. Second, you need to find distance traveled by balloon in 10 seconds, and it is given that this, let's suppose this is my point O1, so this is O1 P is given to me, and let's suppose 10 meters. 10 meters. Now since it is given that this is first one, it was 60 degree, and next it was moving such that this become 30 degree, which means implies that the since the angle is decreasing, which implies that the distance will be increasing. So next time if you see this, this will be far from this, and since it is moving horizontally, so this will be this. This height will remain same because it is moving horizontally, and this is my, I suppose this is my O2. Now it is given that this O1P is already given to that is 10 meters. Now I am renaming this point. Let's suppose this is my A, this is my B. So and you know that this is with respect to angle 90 degrees. So this is 90 degree. Now, first is how this 10 meters is given to you. And yes, one more thing is given that this is my your angle. This is your angle 30 degree. This was the angle 60 degree, and this was the angle 30 degree. So you from the figure you can see that this O1A equal to O2B. You know this thing. Yeah. O1A is 1 because height is always the same. And yes, one more thing can be done, that is first calculate the third, that calculate the height of balloon from ground. It can be given. It is much simple. So how will you do that? Is suppose this now O1A is your height or O1B is your height. You can take it h. Now so this will also be the h. So from figure 1, that is in triangle O1AP, angle A is 90 degree, angle P is 60 degree, and O1P is given to be 10 meters. 10 meters. So what you need to do is that now for calculating OA, O1P is given, which implies this is nothing but with 60 degree. This is perpendicular by hypotenuse. So which is sine, which is implies that using sine of 60 degrees. Sine of 60 degree nothing but O1A by O1P. 1 is given to be just which is height of the this, and O1P is given values is given 10 meters. And you know that sine of 60 degrees is nothing but root 3 by 2. This will be root 3 by 2. 2 5 are 10. This it's cancelled. So value of height, this is height of the balloon from the ground, is nothing but 5 root 3 meters. 5 root 3 meters. Now how will you calculate the height? You have calculated height. How will you calculate speed? Now first you calculate distance AB. So AB you can from the figure only you can see that is AB is nothing but O1 O2 distance. Why? Because they are parallel. This become a parallelogram. Parallelogram opposite sides will be equal. This is just a mirror image of this point. Now next thing is h1 is given. What is O1A? How will you calculate this O1A? Before going there to here, you from this figure, it means that this h you have calculated and this h can be used here. So for this triangle, now I'm using my different triangle. This is triangle O to PB. So O to BP. So in triangle, so in triangle O to PB, O to PB, it was given to be like this. Height you have already calculated. Height was calculated to be 5 root 3, and this was diagram. This was diagram like this, something like this, and this angle was given to be 30 degree. This was 60 degree, and this was AB. This was 90. 1 O2, and point P was fixed. This angle was 60 degree. Dotted line. So this will be 5 or 3 meters. Now from here you can calculate that this in triangle, first in triangle O1AP, and this was already given to be 10 meters. 10 meters. So in O1AP, now if you want to calculate the value of this P1A, how will calculate this? This is with respect to 60 degree. This is base and this is hypotenuse. So base by hypotenuse is nothing but cos of theta. So cos of 60 degree is nothing but PA by O1P. Now PA is not given. PA by O1P is given to 10, and from cos theta is 60 degrees and a half, which implies this is nothing but 2 by 2 to 5 10, which implies like PA equal to 5 meters. So this we have calculated as 5 meters. Now this you have A1P, you have AP is you have already calculated. Now in my triangle O2BP, angle B is 90 degree. You already know O2B is nothing but 1A, which you already calculated, H equal to 5 root 3 meters, and angle P equal to 30 degree. So how I will be able to calculate this? How will I calculate this PB? Now first I will calculate the value of PB. So with respect to this height is given and P is given, and with respect to angle 30 degree, this is perpendicular by base. So tan of, which is nothing but tan. So this is tan 30 equal to O2B by PB. Nothing but this is 5 root 3 we have calculated, and PB you don't know, and you know that this tan of this is 30 degrees 1 by root 3, which implies that PB equal to 5 root 3 into root 3, because root 3 becomes 1 3, so this 5 root 3 is 15 meters. PB is 15 meters. But this AB plus, you know, the AB plus PA is nothing but PB. From diagram only you can see that this AB plus this PA is a whole PB. So PB you have calculated this to be 15 meters, and AB you need to know, find. PA is already given, so AP plus PA is given to, they have calculated to be 5 meters, and this is 15 meters, which implies that AB equal to 10 meters. This is 15 minus 5, this is 10 meters. 10 meters you have calculated. Now it is given that it take 10 seconds to move from here to here. So the speed will be, so distance we have already calculated, so speed will be, that is distance upon time. Distance upon time. And what is distance? It is 10 meters upon 10 seconds. So this is 1 meter per second. It is speed of the balloon is 1 meter per second. It can also ask that find the next line of sight distance of the point of balloon from point P after 10 seconds. So you just need to calculate O to P, that is this distance, which is nothing but if you apply this perpendicular by hypotenuse sine of 30 degree, and sine of 30 degree for H we have already calculated, and hypotenuse to calculate, and angle is already given 30 degree, tan 30, sorry, sine of 30 half. So this value all easily calculated will be 10 3. So this is few application of this trigonometry. Now one more thing is that in this question they can, I will not solve this, I will just be telling how they can give questions. They can give questions like the same question they can give, like a person is standing on the ground and some height h1 is, he sees a balloon for the first time, and then by angle of elevation of to be 60 degree, or if I am not given 60 degree, I can write it as theta 1 degree. Now after 10 second, the after t1 seconds, this angle reduces to this reduces to theta 2 degree, and this balloon is moving in horizontal direction with no changes in this vertical direction. So, and any one distance can be given to you, that even the height of the balloon from the ground can be given. H1, H2, this is H2. Now need to find, suppose this distance, that is the line of sight distance of balloon to the speed can be, you can need to find this, it is t seconds, it moved from A to B. So you need to find the speed, you can you can just find the speed. When you find the distance between this the can be also given to find. This is h1. This you just need to deduct this distance. This much length will be h2 minus h1. You just need to do this. Rest everything will remain same. Everything will remain. The same can be given to you from this top of a building. Now how will we start given to the top of the building? So from top of the building, it can be given to be like this. This is, suppose this is the top of the building, and suppose uh, there is a turtle here, or is a rabbit here, negligible length. It is running at a speed, some speed, and after some time, it reaches here from A to B. It was earlier at point A, and next he moved to point B. But this time, only one of the angle is given as theta 1, but this height is given to you. Now we need to find this angle theta 2. You may need to calculate this or this also. Even since it is also time was given, that is t1 seconds from here, so you might be able to find the value, maybe asked to find the value of speed. What was the speed? So just applying the trigonometric formula, you can easily calculate the value of speed, time, height, angle 1, angle 2, this is angle of depression, angle of elevation, the distance between the two, the length of the object. You may need to find the length of the object. Suppose there is some length of this object in the same question. Suppose this is the height of the building. This is the height of a building, and there is a truck where Almira, which is getting lifted from A to B. The height of Almira is not known. But let's say this is h1. The height of the building is given to h2. Height you need to just h1 you need to don't know. You need to calculate but h2 is given, and the angle of depression of from the point can be given. This is theta 1. This is theta 2. Remember that this theta 2 is always less than theta 1, because as you move far away from the point, this point from here it is far away, getting from here to here, this is getting far away, so the value of theta decreases, and as you move towards the point, the value of theta increases. This is the basics. So in my next lecture I will be covering the examples and exercise. Keep watching and like and subscribe my video. Thank you.